Plastic remains one of the most used materials for making many of the things we use in our everyday lives. Things made of plastic can be very strong and last a long time. They also do well in extreme heat and cold. Plastic is also much lighter than metal and can be easily formed into different shapes. This makes the material ideal for countless uses across many different industries. But the widespread use of plastics across the world is causing major problems for the environment. Plastic material is flooding landfills and causing severe damage in the world's oceans. Plastics can take hundreds of years to break down on their own. Very few kinds are highly recyclable. This is because of the way plastics are formed. It has been estimated that even the most reusable kinds of plastic can only be recycled at a rate of 20 to 30%. Even when recycling is possible, the process is costly, can use a lot of energy, and in many cases produces poor quality materials. But a team of researchers working at the U.S. Department of Energy says it has created a kind of plastic that could lead to products that are 100% recyclable. The team works at the Department of Energy's Lawrence Berkeley National Laboratory in California. It recently reported the discovery in a study in the journal Nature Chemistry. The researchers say the new material is a plastic polymer called polydicotonamine, or PDK. The team reports that the material can be broken down in parts at the molecular level. It can then be built up again to form plastics of different shapes, textures, colors, and more. The researchers say this process can be repeated over and over again without the plastic material losing any performance or quality. Most plastics were never made to be recycled, lead researcher Peter Christensen said in a statement. Christensen works at Berkeley Lab's Molecular Foundry Center. But we have discovered a new way to assemble plastics that takes recycling into consideration from a molecular perspective. The team explained that all plastics, from water bottles to automobile parts, are made up of polymers with a molecular structure. These polymers are made up of carbon-containing compounds known as monomers. Many plastics have different chemicals added to them to make them more useful and powerful. The problem is that these chemicals attach to the monomers, which remain in the plastics even after the material gets processed at a recycling plant. The research team reported that with the newly discovered PDK material, the monomers could be recovered and separated from any chemical additives. This part of the process would involve putting the plastic material into a highly acidic solution. Brett Helms is a scientist at Berkeley Lab's Molecular Foundry who worked on the study. He said the team is interested in the chemistry that can redirect plastic life cycles from linear to circular. This could be especially important for materials that currently have very few recycling possibilities, he added. Next, the researchers say they plan to develop PDK plastics with a wide range of thermal and mechanical properties. These plastics could be used for many kinds of cloth, as well as things such as 3D printed materials and foams. In addition, the team is looking to include plant-based materials in the process. Helms said the world is currently at a critical point at which new recycling plants and processes need to be developed and modernized to deal with long-lasting plastic waste. New recycling centers could be designed to recycle or upcycle PDK and related plastics. Then we would be able to more effectively divert plastic from landfills and the oceans, Helms said. This is an exciting time to start thinking about how to design both materials and recycling facilities to enable circular plastics, he added. I'm Brian Lynn.